All right, hello everyone. Happy New Year. Welcome to the Road to the Metaverse Creator Series. In today's session, we're going to learn to bring Internet of Things data into your Unity XR experiences. My name is Drew Demokas, and I'll be your MC for the session. I joined Unity back in 2020 as a creator and developer advocate focused on showing businesses how AR and VR can solve problems and modernize old processes. Now let's meet the rest of our hosts, starting with Jerome.
Hello everyone, I'm Jerome Moret-Delaunay, and I am based in London, UK. I'm a senior creator advocate on the industrial/digital twin team. And yeah, Happy New Year to all the participants, old and new. Glad to see you on the other side of 2022 and now 2023. Looking forward to the rest of the series. And with me today is Vanessa, as usual.
Yes, hello, I'm Vanessa, and I've been at Unity for roughly, I believe, 5-6 months. And I'm a creative advocate, and my background is in computer game development, and I'm here just to support the Road to the Metaverse series.
And I want to welcome a new special guest to the series. Sorry, Drew, I hope I didn't cut you off.
That's okay. Go ahead.
We have John joining us today. Welcome, John.
Thanks. Welcome. I'm John Futcher. I'm based out of Buffalo, New York. I'm also a senior creative advocate on the same team as Jerome, supporting all this great stuff.
All right, awesome. Thanks, John, and welcome. And thanks, Vanessa and Jerome. And yeah, thanks to everyone for attending today, and Happy New Year once again. Glad to see everybody in the new year. So as you can all see, we have today's agenda on display here. So following a quick intro, pretty quick today, we're going to go into today's main topic. So before we get started, if you have any questions at all, please pop them into that Q&A pod on Zoom. It's always great to have a conversation going in the chat, but if you want a question direct to us, just make sure it's in the Q&A pod, or else it might get a little buried and lost. And also, as always, we're looking to hear from you about how we can improve our presentation. So we have a survey available for today's live session. It's at the QR code on screen and at the link that I'll pop into the chat here. And there we go. Yeah, we really want to be able to keep doing talks like this, and we need positive feedback in order to keep on with these kind of series. So please fill out that survey when you get a chance. So before we get started, I'm just going to highlight a few quick and helpful resources. The first of which is the Road to the Metaverse Executive Series, which you may want to check out. In this series, Ryan Peterson, Unity's VP of Professional Services, is joined by special guests, and they tackle the why and how behind this new era of consumer and social experience. These chats are designed to spark the imagination, and all end with live Q&A. There are currently 5 episodes on demand at the link and QR code on screen, as well as a new session coming up on January 24th. So please check those out when you have the chance. And as usual, I'll just quickly fire a link into the chat. We also have our Metaverse Minute blog. There's a number of great stories to be found in this blog, and many of which I've actually featured during intros for our series here. So please check that out as well. And bear with me here as I throw one more link into the chat. And finally, just relevant for today, if you'd like to learn more about the basics of the Internet of Things and digital twins, I'd like to direct you to this article by Caroline from the Digital Twins team. This article is a great primer on both IoT and digital twins, as well as how they can be used together to improve workflows, lower costs, and gather rich data. So once again, QR code and link, of course, and all of those links are available in the chat. And with that, I'll hand things over to Jerome.
All right, thank you, Drew. Let me grab the share. There we go. And I'll move this window here. Apologies. Get myself situated. So yes, really great article. I wish I had it when I was doing research on IoT. Lots of good resources. Unfortunately, just found out about it yesterday. So, but that's cool. Lots of great links and use cases across the industry. So highly recommend a read through. Going back to this series, I wanted to highlight again that we have a dedicated GitHub organization called Road to the Metaverse, where we've been uploading a lot of the projects that we've shared with you, both on the Learned series, which is the sister series to this one. That's next week episode on Intro to AR, and also this series. So there's 4 projects for episode 4 and 8, I believe, along with episode 9, for example, for the Learn series. And obviously, everything is also posted on the forums. If you haven't joined them, please join the forums. Ask any questions after these sessions that you may have, or share content that you create with some of the resources that we're going to share today. That'd be great. And that's also where you can go back and find all the slides and link to the recording that are available for this series. So let's kick into high gear and go into introduction. So integrate cloud-based IoT data into your XR experience, actually into any Unity experience, XR or not. First of all, I wanted to kind of lay the groundwork and discuss what is IoT, right? Might not be obvious to everyone, although it's a term that's been tossed around for a few years now. And basically, IoT is the Internet of Things. It's a describes physical objects that are embedded with sensors, software, and other technologies like machine learning, AI, etc., network together and exchanging data with one another, right? Usually across the internet or private networks, if that's the case. And there's various examples in real life, from a connected, for example, piece of machinery or a coffee maker in your house to connected cars, connected homes or smart homes, things like Alexa, Google Home, Apple Kit integration, your Philips Hue lights, for example, or smart lights, smart devices from IKEA that are now also on the market. And then we go into smart buildings. So for operational services, being able to see all the sensors, the status of all the systems within a building, getting more and more complex and tricky to manage, right? With a lot more technology making its way into this infrastructure, and then obviously extrapolating into smart cities, where you aggregate all of the public services, for example, into dashboards that allow you to monitor the state and health of a city, right? And pretty soon, maybe even its citizens, if we start to embed ourselves with more and more devices that are connected. So this all runs on top of various protocols. It's not necessarily a cohesive space. There's a lot of different ways for these devices to communicate, whether they're open protocols like the one that I list here. Most of those are open source or open standards, but there's also proprietary ones, which make interoperability more complicated. As I mentioned here, we'll share the slides, so don't worry, you don't need to screenshot anything, but there's links actually to all those protocols. And some of those might be familiar to you, like HTTP or WebSocket. If you work in robotics, you probably have heard about OPC UA, which is quite adopted when it comes to controlling or monitoring the states of robots on the factory floor or else. And today we'll be talking about MQTT. So that's the message queue telemetry transport. I learned that a few days ago when I created this slide, although I've been using MQTT for a few months now to prep for this session. There's also a new protocol that I wanted to mention, which is called Matter. This was a hot topic at CES this year. Matter is a cross-industry consortium, cross-industry consortium that is in trying to bring interoperability between all the systems, things like Amazon Alexa, Google Home, Apple HomeKit, but also all the smart devices from some of these companies. This is a sample of the logos from their website, so you can see there's a lot of adoption behind this standard. And one of the key components of Matter is that it also tried to solve the issue of internet loss. So you have a lot of connected devices, smart devices that interoperate when connected to the internet. What happens if you get disconnected? Usually everything breaks down, so you can no longer control the devices in your home. And this protocol or this system will aim to solve this issue and make sure that devices works not only online, but also offline, which is great. If you have a smart home, that's usually the first thing that you can't control anymore when your internet goes down. But today we will be talking about MQTT. MQTT is a really light, scalable protocol that you can use to interconnect devices. It's very simple, very much so like a broadcasting system. So you publish data through topics using MQTT to a broker. A broker can be on your machine locally, on your computer, can be online on a dedicated server, or a fully cloud hosted solution like the one we're going to be showcasing today. And then clients can register or subscribe to various topics, right? So channels basically of information, and receive notifications when a message is sent to that channel. So it's really quite simple, really easy to integrate, but also quite ubiquitous across the industry. So whether you're using Azure IoT, AWS IoT Core, or something like Abli for real-time communication, they all have compatibility layers with MQTT. So if your application can consume MQTT, then it's quite easy to register with the brokers. So that's what they call kind of this. There are servers that are hosting MQTT services. It's called a broker. And all of the major cloud providers or real-time data providers have an MQTT broker compatibility, or even their own solution to interoperate. You don't need to sign up for, some complex cloud backend. You can use public servers. Mosquito and Eclipse both provide public free servers. These are public servers, so be mindful. Don't use, sensitive data with those. But if you're doing a little, want to create a small demo or just test what we're going to show today, then that's a good way of doing so. They're public servers. You don't need any credential. You just connect and send messages to create a channel or a topic, and then you can send messages to those. Again, be mindful that these are public servers, not privately hosted. If you want something a bit more secure and contained, then we'll be using today HiveMQ, which is a dedicated cloud service built on Azure. That's provide a really easy to sign up, free to use tier for connecting up to 100 devices, and I think they provide about 10 gigs of data. Actually, I have. I'll show you later the setup. It's a cloud hosted broker, and obviously they can scale this to whatever you need, but also no credit cards needed. So it's cool. You don't even have to sign up with a credit card, which makes things a little bit easier. And we're going to jump into the first part of the demo, which is creating connected applications with MQTT. So as I get set up, do we have any questions or anything before we jump into?
Nothing in the Q&A so far.
All right.
We're all good to keep going.
Everyone is attentive and listening. Brilliant. So let's jump in. Drew, if you don't mind popping in the Furious link in the chat for everyone to connect. So I'm going to show you today's demo. Thank you. There's a few, the link is in the chat. You can connect to it. Hopefully it'll connect pretty quickly. I reserved or pre-allocated some servers for you to test the app, but it's pretty quick to sign up. So I'm going to start the application on my end. This is the console application from the demo today. And don't worry, I'm going to run through, walk you through how we set this up, but I want to show you what we did. So there we go. We can see in the console log that I am connected to a MQTT broker, which is the one that I've set up on HiveMQ. I'm going to maximize my screen. And then you can see here that I have a few controls, so I can turn lights on and on in this office. So the synopsis, the idea here is I want to visualize, but also control lights and temperature in an office space. You'll see why I limited this to 8 in a second, but basically I have a user interface that allows me to set the temperature into the office. You can see that the temperature, when it gets hotter, becomes red. And then here I can turn the lights on and off. And hopefully this is also showing up on your end. The dashboard should pick up the state of the application as I change these values. Now this is using software here, but I can also switch this to hardware. So let me switch my webcam to my desk view, and you can see here a small MIDI controller that I have that is connected to my application. This is just to simulate, let's say, hardware that could be inside the room. And as you can see here, I'm changing the temperature of the room at the bottom right corner of the screen, but I can also change the lights, turn them on and off based on the state by just tapping on those buttons. So we basically taking hardware inputs and mapping them to a connected application, right? This dashboard is, I'm not directly modifying the state of the rooms in the application. I am going through an online broker to do so. So I'm just sending messages to the cloud, and then the applications handle those locally. So that's the idea here. Now, let's talk a little bit about setup. To start, first thing first is I went to this repo, which should be on screen now. Sorry about that. There we go. So there is a M2 MQTT for Unity repository that you can just check out. This is a full Unity project. Includes, if you look into the assets, you will see that there is a M2 MQTT folder. That's actually the .NET library that's compatible with Unity, and then a small wrapper that is used to work inside the editor. So you can see them here in my project. I have the M2 MQTT implementation. So that's the .NET library. And then the small Unity wrapper. The Unity wrapper basically just provides a way to add a game object that has all of the credentials in order to connect to the MQTT broker. So I'm not a big fan of having all of these settings inside the game object, because when you work with multiple providers, or if you want to have, let's say, like a development server versus a production server, it gets cumbersome to manage the settings here. So the first thing that I did, just to simplify a little bit my work, if I go back to my console, you will see that I have the same N2 MQTT, but my broker is using a scriptable object, which you can see here. I have a safe version that references the server, the various credentials. Here, for example, we're using an encrypted connection versus the public one that doesn't. And also we have a username and password plus the topics. So that's, kind of the setup here, but it's using basically out of the box what was provided inside our repository. On top of this, as I showed in the webcam, as you can see here, I have a MIDI controller. That MIDI controller is using Mini's VS from Kijiro, which is a visual scripting implementation of a MIDI interface, which allows you to basically get MIDI command inside visual scripting. And then to wrap it all up, I'm using the notifications for visual scripting. If you have been following this series, that's something that I've been using pretty much for every episode where we had complex systems to decouple communications, available on our GitHub repository. It's super convenient. And this is where this actor here comes in. So working in with MQTT, inside Unity, that's pretty much all you need to get started. And then I mentioned Hive MQ, which I have here. This is the connector, and you can see that 10 people are connected. We're connected 5 minutes. We're connected right now to the demo, and this is the amount of traffic. Basically, it gives you this URL with the ports, and then you have a convenient access management where you can define username passwords in order to share the credentials with everyone. So these credentials are embedded inside the Furious application, and here is where you can see the current dashboard. So we have a little bit of headroom when it comes to data. We can keep playing around for a while. So let me go to my note. So that's pretty much the setup. Now, working with MQTT inside Unity, as I mentioned, basically you have the broker connection manager. Its role is to connect to the MQTT broker using the settings here, the smart object, or the scriptable object, that I mentioned. And then I have this, it's basically the same as the M2 MQTT Unity client, which is what came with that GitHub repository. I just not even extended the class. I just created a new one that had pretty much the same code, with the exception of bubbling up a few more events that I needed for the lifecycle of the application, because I have this little C# class that I created for the demo today, which is a notification relay. So that's basically registers itself with this object or with the manager, and then sends it a notification that the application wants to send a message to one of the topics, or bubbles up whatever messages come in from the server as a notification to the rest of the application, basically to the rest of the scripts that need to handle those. And as you can see, what I mentioned before is right now I'm connected to this MQTT Hive server, but I can also here, for example, pick the Eclipse one, which is this one, which references the same topics, but is actually public. So if I press play now, and if you're still connected to the application on Furious, or if it's still running, you won't see any changes now when I'm using this server. Here I can change the light. You can see it's a little bit slower because I'm using a public server, so there's a bit of a delay when I click versus when something happens. And obviously it's not updating if you are inside the Furious instance, because I'm using a different broker here, right? But conveniently, if I go back to this, to my game object here, and then select the demo one. I have two because one has the password that you can see and the other one doesn't. I'm not crazy. So I want to share the password live because people are going to start tinkering with that stuff. So now if I press play again, the credential have changed, but the instance on Furious that you are looking at, or I don't know if John, you have your a copy open, then, you know, everything now should be working. You should see the state of the application changing on your end because we are basically connected to the same broker. So it's as simple as this. There's really not much more to do except to register for topics. So this is where this list here is basically all of the topics that I'm using. Topics are channels. So we have a channel. CC is continuous change. So if I go back to my desk cam here, it's this knobs, right? They go from 0 to 1. These are standard MIDI value. And then the T stand for toggle. And this is those pads, right? That I'm using to send basically true or false, toggle between true or false value. So that's the connection settings. And then, as I mentioned, this relay here, this application, super simple. It's a C# script. It references 4 notification types, right? A message decoded, publish, connected, connection succeed, and connection failed. And then registers itself with the connection manager to get some messages, but also calls some messages, calls functions on like publish, for example, on the connection manager. So very, very simplistic. And then you can see here, this is the meat and potato of sending events from C# to Visual Scripting using the event bus. This event bus is a Visual Scripting class that you use to send events to whatever Visual Script can handle them. Very convenient when you're creating like hybrid systems like this. Now, let's switch to building the demo. As you see here, there are 2 scenes. We have a console scene, so and another one, which is the dashboard scene. So don't save. When you're looking at the Furious version, you're looking at the dashboard scene, basically, that's published. This one is non-interactive. The user interface doesn't do anything. And also it's not handling any MIDI inputs. You can see here, the MIDI component is gone. And well, the UI kind of looks the same, but only the console, this version is interactive. So these I have locally running in the editor. I could publish this to Furious also, so that someone can handle interact with the console and someone else can visualize the result in the dashboard. So today we'll walk through this console because it has obviously all the functionality of the dashboard plus some more, right? So and as I mentioned, both the console and the dashboard listen to events from the broker and updates their states based on that, right? They don't directly manipulate anything, including the user interface, right? The state is controlled by the messages from the broker. Talking of user interface, let's start with that, actually. So if you follow the series, the Learn series, we did a whole session, 2 sessions ago, I think, on building user interface. So very simple. We have a canvas here, which is workspace, but it could be, which is screen space, but it could be workspace easily if you're doing an XR version of this. A panel, and then the thermostats here are basically prefabs, which I created. Each prefab has a script machine, which is called a radial slider. I can double click to go into full screen here. So this is quite a MIDI script. There's a lot of stuff happening, but basically I took this UI extension script called radial slider from an open source project called Unity UI Extensions on Bitbucket, super useful, and recreated it quickly with Visual Scripting. If you're wondering what is this, if you've been using Visual Scripting, this is version 1.8.0 that just was released right before Christmas. And it includes now sticky notes. So we can put little comments, sticky notes inside our Visual Script, super useful when you collaborate with others so they know what you are doing. So for example, here, This is pretty straightforward. We have some pointer inputs, like on drag. When I drag my mouse, basically it just updates the radial value of that slider. And I'll show you that in a second. You can see here the object variable. So we have, for example, the topic that we are listening and also sending messages to, in order to update the value of this of the temperature, right? Again, we send the values from 0 to 1. And I have a little sticky note here to highlight that although we are doing this, when the pointer and down, when I drag on the component, I am going through this flow, which is on update. So every frame, that could be up to a few hundred times a second, depending on your frame rate. So just to avoid sending too many messages, I have this really useful node, which I wanted to highlight, which is called a cooldown. A cooldown, basically, this will only trigger every half second, no matter how many you call it, how many times you call it. Obviously, the first time you call it, then every half second after that, it will trigger the onComplete and then send a notification. So it's a good way to throttle kind of, how many times you're going to call an actions, but, keep it connected to the on update so you don't have to have separate logics. So that's wanted to highlight this. And basically every time I click on this, you'll see, I'll go back into play mode quickly. There we go. Wait for it to connect. There we go. And then you can see that when I click and drag, the slider value gets updated, and then we are driving a little radial value for this button. Changes the color using the cooldown to change to send that instruction to the server. And I wanted to show quickly, this is a super useful thing. If you look at the outline, right, you can see here there is an outline, but actually you can't really see it in the editor. Let's focus on this. This is because we have a fill amount here. This image is set to field radial 360 and with the origin at the top. And if I increase the value to 1, you can see this increase. So it's a really cool way and quick way to do radial progress bars, etc. You just use this. It's built into Unity. You can even decide where does the field starts at the bottom. I'm using top because when you click and drag, that makes sense, that aligns. And then you can even decide to inverse these to clockwise or counterclockwise, depending on what you want to do. So it's a really easy way to do this. It works with fields too. This is just a circle image, as you can see, and it's fully filled. And you can also control this if you want to do this type of user interface. So really useful little trick with the image component of Unity that I use here for those thermostats. Next up is the light toggles. So this is the next row below. Let me focus on this by pressing F. There we go. So again, this is a toggle component, super simple. Has an is on component based on when you click, right? And it will toggle automatically for you. And you decide what's the graphic that's going to be driven by is on. So this is on and off when I turn it. If you define a toggle group, basically it will solo select one item in that group and deselect everything else. So it keeps track of things. The few things I want to highlight here again is this is another prefab that I've created. It's a little bit simpler. It just references one variable, which is this MQTT topic that is going to listen to, but also send instruction to, or send as its value to update. And then a simple visual script called VS light toggle. And if we go overview, there's not much in there. You can see that we have a built-in event from visual scripting that handles the toggle events. You can just add this, add node, and then look for toggle, and this will give you actually on toggle, let's say. And you will see on toggle value change, and that's what you use to create this node. And then every time you click on the button, this will get called. And here what we do is we send an MQTT publish message notification with our topic, so that and the value of the toggle, which is passed by the node, by this unit, and just send that over to the system so everyone can update their states. On the other side, we also listen to every message that's being decoded from the MQTT server, check if it's our topic. And if it is, we parse the value that gets passed with this notification as a Boolean, and then assign that to our toggle component. And I wanted to highlight this function here because you can set the is-on value, and you can set it without notifying the rest of the application. This is super useful if, like in this case, you have on toggle change listeners. So if I wasn't using this here, I would change the value, then this would call, and then this will change the value, and this would call, and you get into this infinite loop of updates. So what happens here is change the value, but doesn't trigger the on change event. So FYI, this is a really good way of avoiding those endless loops of updates. And that's it. So as I showed in the with the physical version of this system, so this component, I have 8 pads and 8 knobs to control. So this is why they are 8 and 8 in the user interface, because that's all I had as far as hardware on this MIDI controller. Talking of which, this is where the MIDI controller action lies. Super simple. Again, this is using Mini's VS from Kijiro, and it looks complicated if you do an overview, but actually it's basically 8 times the same thing in each columns here. So here we have the continuous change, values from 0 to 1. You can see that, you know, there's 8 of them. It goes from 1 all the way to 8 here. And basically all it does, it sends on update, whenever that value changes, sends a or request that a MQTT message be published with to the correct topic with the value of the control. And then on the other side, this is for the pads, basically, which are treated as MIDI notes, just like a keyboard. And based on the note, again, we have this convenient toggle flow unit here that basically keeps track of a toggle and then swaps it for you whenever you call toggle. So it starts false, and then the first time you press, it goes to true, etc. So really convenient to not having to write a custom or hold a custom variable just for this. And then same thing, every time the toggle changes, whether it's on or off, both flow into sending a message via the MQTT broker saying with the value on or off for this channel or this topic, right? And again, we have 8 times the same thing based on the 8 keys in that MIDI controller. I know it's a lot, but yeah, I think it's about it for the interactive bits. And then, as I covered the UI already, then we have the actual digital twin. So this is the scene here. If we look, there you go, at these controls, right? So this is our office or simulated office space. You can see here this room, which is basically a box, right? Simple. If I hide it, you can see it's a box. And there's 2 main components in there. Again, that's a prefab that I've created with a custom script. Really, really basic. So we handle notification when an MQTT message is decoded again from the broker. If it's our topic for the light, then we turn the lights where we update our light, which is basically turning it on and off based on the value that's being sent. And if it's our temperature topic, then we update our temperature display, right? We update its color, and you can see here I have 2 custom events. So I'm using custom events. I don't have to. I could have gone, you know, I'd keep daisy chaining the flow this way, but I like to break it down into this kind of, you know, repeatable or reusable little module. So a custom event allows you to, you know, you can send call this within the graph multiple times if you need to. And in this case, because this is a pretty standard function of this component, it's kind of nice to have it encapsulated into a custom event. So, it's update light, update temperature. And as you can see, we have a light display, right, which is this object here, which is a game object, and then we have a temperature display, which is a mesh renderer, and we change its color based, or we lerp the color value between the min and max color based on the value that's being sent from the MQTT broker. If we look at how it's set up, you can see here, I'm gonna turn this light on and off. You can see it's just basically a point light that's in the room. Some rooms have multiple point lights, but this one has one. So based on the state of the application, this will get a trigger on and off, and same with the temperature here, which is basically just a cube. You can see it. It's a cube with a material, and then its color gets changed based on that value. So pretty straightforward. Again, we can go back into the demo now that you can see better what we are doing. And update the values. So if we select this component here, you will see, sorry, and let's overview it so we can see a little bit better. As I change my temperature, you can see all the little dots are fully lighting up. Let me, here, we can, there we go, expand this a little bit. So you would see here, right, that when I change this value, I'm changing the temperature, and then every time I toggle the light toggle goes on and off. And again, if you're still connected to the Furious experience, this should update because we automatically connect to our MQTT broker as we do this, right? So all these, and you can see here, because I'm tweaking a value that's not this component that I have selected, it's not room one, it goes up all the way to the if here, and then drops off, right? You can see that this is false. This was not our topic. We don't care about this topic, so we don't do anything. Whereas if I change this one, you can see that, oh, sorry, that's the light topic. So if I change this one, you can see that, oh yeah, this is our light topic, then I'll update. But if I change this one, it stops at the if here and doesn't do anything afterwards. Right. So very simple. And then we have a nice office floor for the visuals. This is from the asset store. I have the link in the slides afterward. It's called PolyOffice from a creator called It Happy or IT Happy. Really brilliant. I think it's 60 euros. It comes with 5 floors, a whole bunch of room, all of those assets. It's really good. Asset to use, and all I did is I took 2 of its floor 1 and floor 2. I hid some of the components of floor 2 to basically make 8 rooms, and then duplicated that object 8 times to create all the rooms. So, very simple way of creating a small digital twin of an office, obviously for display and representation. And just kit bash together those 8 rooms. Obviously, also to keep Ben happy, because I know he's watching. I did a little bit of post-process to make the thing a little bit pop a little bit better. Not much there, just a bit of bloom, tone mapping. Always use tone mapping with ACs, makes everything look more dramatic and cinematic. And a bit of color adjustment for the post-process to brighten things up. Again, this type of usage is really useful for this type of post-process is really useful to bring up a little bit the quality of your visuals. And that's about it for actually this demo. Let me go back into play mode. I just wanted to fire this up behind. There we go. And go to maximize so we can have a bit of a view here.
Well, you might notice some of the
what's happening?
Some of the values are changing on.
Yeah, John, are you tinkering with my demo?
Maybe.
All right. Anyway, so I wanted to mention some of the important. This is freaky. I'm not touching anything, right? I wanted to talk a little bit about the next steps or improvements that you could do to this demo. As I showed, there's about 16 topics that I've created for this, 8 for the lights, 8 for the temperature. This is truly overkill. You should probably just have 2, one that handles true and false toggles, and the other one that handles float values like 0 to 1 or whatever you need, and then probably send a small JSON object with the ID of what you want to control along with the value that you want to apply. I didn't want to go into JSON parsing and creation here, so I figured we'll just use individual topics, which makes the whole thing a little bit easier to demonstrate. Obviously, you probably want to update the states of the dashboard when it connects, because things may have changed in between sessions. So this is something that I haven't done, but it would be really good to kind of go through. MQTT can keep a historical data on the server, so you can go back like a half hour or the last 10 instructions, or make sure that you have all the latest values that were sent in previously reflected in the dashboard when you connect, for example. I think it would have been cool to also have like a first-person view inside the office. We didn't have time to do this. And maybe even one of the ideas that I thought would be cool is to have little NPCs moving about the office, and then turn off the lights and lowering the temperature when no one is in a room. And you can create little systems like this that can sort of simulate behaviors and create smarter connected things. And just to wrap it up on my side before we see what's happening, here are the links to the resources. Again, the low poly interior from IT Happy, really recommend it, great asset. M2 MQTT, that's the library that we're using, John and myself, to create the demo to connect to the MQTT broker and the visual scripting notifications. That's on GitHub. As usual, we'll post the slide after this session on the forums. And next up, well, we're going to switch to John's presentation.
Well, before we cut over there, why don't you bring yours back up and explains, like, you can see that these values were changing on you.
Actually, sorry, if anyone still has the link to the Furious instance, you can connect to it and see this live, right? This is not only on my end, it also works with the Furious version of this application. Go ahead, John.
Right.
Sorry.
So you see all the values changing, the top 4 kind of changing together, and the bottom 4 kind of moving and getting new values. And you're not changing anything. You're not touching anything. So where's all that coming from? So while you had yours open, I had mine open, and I'll take this over and then jump over and show everybody what's going on here.
Now that's the power of using a online broker, is we can all connect, right?
All right. Can everybody see this here?
Yes.
Well, yeah, and so everything that Jerome showed was really very cool and very awesome. You want to set yourself up. You want to be able to speak with the broker, get your data from your devices, and get that into your digital twin to show the simulation. But what if you actually wanted to connect real sensors and get your stuff into Unity that way? Well, what we have here is actually this, which is sitting on my desk right now. And I'm controlling these values with these sensors and a little breadboard that I've got set up on my board. So if I twist this potentiometer, you see the values on that top row go up. And then right here, we have an ultrasonic sensor, which is a distance sensor, which sends out a pulse. And if I put my hand in front of it, you can see those values go down. If I move it back out, they go up with the distance until it kind of hits the stuff that I have set up over here. So this is actually how you get like real sensor data into the system. And so I've got this Arduino wired up with this breadboard and these sensors. Let me talk a little bit about how we got this set up. So I'll bring this right over and oops, wrong button. So first thing, you can buy all types of sensors off the shelf that are connected to the internet. You can also get things that are built for IoT. You could have sensors already in place in your digital twin or your actual offices. But also you can build your own. You can get little sensors that are set up and you can use things like an Arduino or a Raspberry Pi to integrate those sensors to test them out, prototype them, but also use them directly, get that data directly and use it in your digital twin. So for this, we used an Arduino, which is a really cool open source electronics platform. It's set up so it's got all types of different form factors. They're very small, they're very simple to use. That along with the Arduino IDE, which is the free IDE that you use to program the Arduino. It gives you basically all the basic stuff you need to get up and running, access to the pins and the data that's going to come in through the Arduino. And to use this, to set up this specific demo, we used an asset called Uduino. You can write all of the serial port communication yourself. It's totally doable. It's, you know, something you can do directly with Unity. But for this demo and just generally, I really like this asset. It gives you a lot of great functionality. If you're working with Arduinos, it's got setups for all the different boards that are out there and gives you very simple, easy access to like all the pins and data that you get in out of it if you know some basic electronics. So to use all that, we have this set up right here. And I can quickly move the Zoom stuff out of the way so I can stop playing and show you how we set this all up. So after getting the actual Arduino and the breadboards kind of set up, we're not going to cover the electronic side of this today, but
Oh, no.
You can see in the little image that I had set up, you know, I've got an Arduino, it's wired in to various pins and it's running. Well, the first thing to do if you're going to use this platform is basically we would import the Uduino package. And again, you can write all this yourself, but I do recommend this Uduino package. It's got a lot of cool stuff. And once you import it, you basically have this folder right here in Unity. And all you need to do to get up and running is the first thing you'll do is you'll grab this prefab and you'll drag it into the scene. And then in the scene in the inspector, you'll be greeted with this component set. So you'll see that we already have this one set up right here. But this is the steps you'd want to get it set up your own. So first thing you'll do is it's going to ask you to pick which board you want. It has support for all the different Arduino boards that are out there. And the other thing that it does is it comes with a set of templates that are very nice to get yourself up and running with the board that you have. It'll ask you where your Arduino folder is. So that's wherever you installed your Arduino IDE. There's a libraries folder. When you have this, it allows you it has a button here to move these templates directly to that libraries folder. So I'll say this again, it moves them, it does not copy them. So when you do this, one of the things you want to watch out for is you only do it once, because it'll actually take those files and move them to their Arduino's libraries folder. And when it does that, it allows you to open up the Arduino IDE, just like this. This is what the IDE looks like. And once you have it open, you can go to File, or we can go to File, New Examples. And we've got some basic examples that Arduino comes with, but also we go all the way down here, we go to your Uduino and we can pick some different examples it comes with. That's what that button does. It copies all those things and it automatically adds them to the IDE. So you can click this button and it just pops open a new sketch is what they're called in Arduino, the different sketches. It pops open a sketch already written for you that has access to all these different kind of pins. You know it's already going to compile, and then you can kind of push it over to your device. So using that template, I wrote our own sketch, which is this one right here. So I started with that template that was copied over from that asset. And then I modified it. I added some other different things that I needed to run the ultrasonic sensor, like setting up the trigger pin and the echo pin, so I can get the different distances. I added different libraries and so forth. And this is all fairly straightforward if you worked with this stuff before. It's great to have that template to kind of build on top of, so you don't need to learn all that stuff from the scratch. You can kind of build on top of it. And then all you need to do is basically hit this button to compile it. And then this button pushes it to your device. If you have your Arduino device hooked up over USB, if you're already connected to it, you can press that. It'll push that over to the Arduino, and then the Arduino will run on its own. It's a microcontroller. It has that code on it. When it fires up, it'll run that code every time you fire it up. So then you can like detach it from your computer, and you can reset it, put it in something else, hook up a whole bunch of other sensors, run it off a battery. Have it anywhere in your, in your building or your actual, operating facility or on whatever tools you're working with. And it'll run, that's all you got to do. You push it to that once, it'll run. Once it compiles, it'll run on there. It's set up kind of forever. So once we have that on our device, I'm not going to push this over because it's already hooked up and it's running. Once you have that all set up, you can come back over into Unity and you can see there's another setup over here in the inspector with this button called Discover Ports. So if I hit that, it's basically going to search the serial ports on the computer for any Arduinos that are already hooked up to the machine. And so I already told it I have an Arduino Uno, it's hooked up over USB. And I can see here, oh, it found it. It got a message in it. It knows it's this Arduino board came from a sketch. This is a message that's running from that sketch that's running. It says it's connected. And the next thing that we need to do is we can set up the pins that we want to use. So if we're actually getting data off of the sensors, again, we're not going to get deep into the electronics today, but the pins basically get set high or low based on the voltages. And these are the things of how you actually like run the logic and get data out of your system so you can use it with your digital twin. And this asset has a really cool way that's going to set this up right in the inspector where I can just hit this button to add a pin to the list. And I know because I wired this, and if I opened up that window again, I could show, well, that's got to get previewed back up again. One second.
We are live, people.
You know, things love to go to sleep when you're live. So
It always happens, always.
So if we go back to this,
Arduino is I think a $15 asset, right?
it's very, very affordable and very much worth your saving your time. But again, I will reiterate, you don't need it. You can do all of this without it, but I highly recommend it. So if we go look at this board again, so this is the Arduino board right here. And I've got, without getting deep into it, I've got like voltages and grounding coming out, and it's all wired into these various sensors into this breadboard. And I know that the data coming back from this potentiometer is wired back into the analog 0 pin. And that's the data that I want to read. So if I want to take the twist of that voltage off that sensor, that's the one I want to read. So when I go back to Unity, I can straight up pick A0, that's my analog 0 pin, and I can set that to as an input. And then I can read from that, and I can just hit this button and I can test to see that I'm getting data in over the messages, and I am getting it's getting messages in, and I can read from that. Similarly with the ultrasonic sensor, this is a little bit more complicated where it's actually sending some data over using, digital pulse wave modulation and doing some things where it's sending out a sound and basically detecting how long it takes for that echo to come back. And that's how it does it as a distance sensor, kind of like bats or like dolphins would like echolocate. And so for that, I know I need access to the trigger pin and the echo pin, and I can choose those right here and say the digital 9 pin is my trigger pin, that's output. And then my digital 10 pin, that's my echo pin, and that's what I want to read back in. And you can actually hit these to send this data back out. Like I can actually set the output, I can hit high, and it'll set that pin, it'll send the communication to the Arduino to set that pin high and to test something. So that's all I need to do to get this basic stuff set up to be able to access the data off the board, be able to read it in, and get that data in. So if you wanted to work locally, you didn't want to work with the cloud, you wanted to actually just have a sensor in your factory or on your tool that you wanted to hook it up to a Unity and run it. You don't need to go to the cloud at all. This setup that we just walked through, that's all you need to do to start reading this data in. And then you can write your own scripts to use that or access it. And I should mention, again, just because we're not just reading data from the Arduino, we can actually send data back out. It works two ways. You can use Unity to control the microcontroller and change values on it to set the different values. So it works both ways. But if you only wanted to work locally, that's all you would have to do, start reading these values in and then changing things if you wanted to use it with your twin. Now, when I was changing the values on this potentiometer, when I was twisting the potentiometer here, and I guess I can hit play again just to kind of show. When I was changing those values, everybody saw those. Like we saw it on Jerome's machine. We saw that those values were coming over. That's because once we're kind of set up and running here, when I was changing these values, I'm reading the data into Unity. Like, so you see my twist, I'm twisting this and you can see the values going down. If I twist this, it goes back up. And if I use my coffee cup kind of in front of this ultrasonic sensor, you see that value get nice and low. And if I back this out, you see, because that's doing that distance sensing and it's sending that data out. Now, if anybody's connected to the Furios, or if you're looking at Jerome's screen, you'll see that those values are also changing. So I'm reading this data into the local machine, but I also want to publish that to the MQTT broker that Jerome had mentioned earlier. So to do that, I just wrote a couple simple C# scripts. We saw the visual scripting earlier, but I just wrote a couple simple C# scripts that read that data in from the Arduino board, getting that data. And then once we're connected to the broker and I know that the data is good, I start publishing them to the same topics that Jerome had showed in the scriptable object. And it uses the same connection data setup that he used, but we're just using straight C# script. And this script sends the distance data to the bottom row. And this script reads the potentiometer and sends it to the top row. And you can see here some basic things of like I can set my pin mode to analog and the fact that I'm going to read from that pin and then I'm reading those values in. And I'm also have like a read rate, so I'm not constantly doing this as fast as computer go. I have it kind of throttled, so it's like 10 times a second or maybe 20 times a second is really all we really need. And that's all I needed to do to get that set up with all the setup that Jerome had already done in the project to get this actual data, reading from a live sensor in my room on a breadboard running on a microcontroller is now being propagated over the internet for everybody else to see and running on the digital twin and that being updated for everybody. That was the full setup, which is pretty fantastic. It was pretty straightforward to get running. And you can see how it'd be really easy to extend this and do all types of other fun things with it. The other thing that I'll mention is that, we showed briefly the Arduino and the setup here, but again, you can purchase sensors that are like internet capable. The Arduino is also internet capable. If you get a component called an ESP8266, it allows you to connect to Wi-Fi. So I could have done the same exact thing here. I can grab one of those, I can wire that in and I could run this off a battery. I could have it on my Wi-Fi. It could also just be running on its own, sending that data up to the broker. And also things like a Raspberry Pi for even doing like more complicated things or cool stuff there. There's lots of other ways to send that data up with MQTT brokers or Azure IoT Hub and anything like that. And they all integrate back with Unity as well. And so, yeah, I think
mess around with your setup by turning the lights on and off here on my
yes, I didn't wire up the lights to these. I kept the thermostats for this data. But yeah, so yeah, that about covers. That's all you need to do to get that direct connection with like sensor data directly in. So if you only want to work local, you can do all that without the MQTT part. If you want this to propagate through the cloud or see the other things, that's all you would need to do to add the other piece to it. So yeah, that's about it on this side.
Fantastic. All right. I'll grab the share and go back to our slides. 1 second, everyone. Oh yeah, by the way, let me share this just so we have it on tape. I'll grab the screen and share. There we go. And here, am I showing the right screen? Yeah. Yes, okay. You can see, thank you, John. Yeah, keep changing the value. So this is the instance of Furious, right? That we shared with you, sorry, in the chat. That's the dashboard. One little thing about the dashboard, as you can see, when John changes the value, it's a lot smoother in the UI. I have a nice little interpolation there to make it so it looks better. It's not as janky as the console, which doesn't have any lerping of the values. So always nice to add those little touches. But as we showed, you can see that if I go into again my desk view here and start turning lights on and off, right, they are controlled. Also, we are both controlling the application. Now John is playing around with the temperature, and I'm just messing about with the lights so the messages don't interfere with each other. But this is the beauty here, is once everything is set up, you can just keep adding devices as long as they communicate through the same channels and you can handle the communications in your application, then you're good to go. It's as simple as that. So thank you, John, for this brilliant session. Again, I'll show this Arduino, literally $15 for anyone that's worked with Arduino in the past without this type of assets. It is possible, but it is painful. This makes it super easy. I know that my friends that are doing installations constantly use this to connect various sensors like, motion sensors and things like that. So they are in Arduino or Raspberry Pi setups. Really, really magic. And yeah, so before we go into Q&A, just reminding everyone, there's a ton of episodes that we worked on, lots of content that we shared. I've seen in the chat that people were asking about today's source code. It's not yet online. I'm using a commercial asset, which is that office. So I need to extract this and replace it with developer art, like nice boxes. So I'll do that after this session, probably in the next 5 to 10 days, and then post it for the full source code on our GitHub and share the link on the forum. So don't worry, but there's a lot of content you can go back to, recordings from last year. This is episode 10, 2 more to go. Super exciting. Workshop, today's workshop was integrating cloud IoT. The next one is going to be multi-user experience, where John and I are going to mess about with some synchronized state on something. We haven't decided yet whether it's a robotic arm. Are we doing a coffee maker? We're going to fight to see who can make the best espresso. I don't know. We'll figure it out, but it's definitely going to be multi-user and connected, with the goal trying to use, out-of-the-box APIs from Unity. And then the next, sorry, this is wrong. I forgot to update this slide. The next, last month was Intro to VR. This month is Intro to AR. I know, Vanessa, you've been working with Vuforia a little bit, and also AR Foundation.
Yes.
All right, awesome. So we're going to be covering AR Foundation 5, with the simulation window that's been introduced. That's for something that was originally in Unity Mars and is now bundled with AR Foundation 5. Super exciting for developing AR experiences without devices, which is, something that a lot of people need. Again, GitHub links is here. It's on the forums, right? As usual. Please don't hesitate to ping myself and Ben. We'd love to see your project, anything that you work on, questions. Don't hesitate to ask. And now let's jump into Q&A.
All right. Apologies for the silence there. I was muted while I was grabbing the screen share. Didn't want to talk over my clicking. All right, we'll jump into some Q&A, starting with our first question from earlier this morning. Any update on USD support in Unity?
Yes, there is official support. There's a USD package. I think it's in preview, I believe, or might be official, actually, I think. So USD is supported. And if you've seen, actually, I know a lot of people are talking about USD in the context of Omniverse, and NVIDIA just announced their official connector for Unity through the Omniverse system. So it's all progressing nicely. But yes, USD is supported. And if you have, there's a section on the forums actually dedicated to USD. So if you have questions, don't forget to post in there. But yes, right, we are working on this. We know a lot of people are interested in USD, specifically in the context of Omniverse, since that's the exchange format. And, on the industrial side, a lot of my customers are asking or already using USD. So it's definitely front of mind for everyone at Unity. That and GLTF, these are the, two formats that are coming out of the gates as the perfect exchange format, open, specifically GLTF because it's controlled by a consortium, where USD is a little bit more nebulous since it's originally from Pixar Disney. So, yeah.
All right, excellent. Okay, going to jump ahead a little bit just because I've seen this question asked a couple times in our Q&A here. What is the MIDI controller being used?
Oh, it's the LPD8 from Akai. I think it's about 40 pounds new. You can probably find them used. Any MIDI controller will do, a MIDI piano, whatever you have. Doesn't really matter. But yeah, it's useful. Yeah, I'll switch to my desk camera. Super fancy today. I have multiple cameras set up, just like John. And yeah, it has 8 of those knobs, which map to 0 to 1 values, and these, which basically just give you a note. You can actually also capture the velocity. So the harder I press, the higher the velocity. So you can use that. It's velocity sensitive. So if you have this need, it's quite useful. But yeah, it's a pretty inexpensive MIDI controller, but any thing that maps to MIDI will do. I use this just to kind of simulate hardware switches or potentiometer, just like what John showed. And it doesn't matter what you use, but sometimes having a physical thing is better to demonstrate. And it's with the Kijiro library. There's a C# library that you can use, and there's a visual scripting library also, which allow you to capture those MIDI inputs and use them in your application. Super useful for this type of hardware debugging.
All right, excellent. Okay, we'll just keep moving right along here. Next question is, would you build this whole application in Unity 3D, or would you want this to be a hybrid solution where you integrate into an existing app or solution for web, desktop, mobile, or tablet?
Yeah, why not? Whatever fits the bill. Again, you can do the full thing in Unity if that makes sense. It's cross-platform. It allows you to target quite a few different devices, including, like things like the HoloLens, the Quest, or, Quest Pro, whatever you deploy to, you can do it through Unity. You can embed Unity inside your mobile application. If you just want to use Unity for fancy 3D rendering, then you can do so. We have Unity as a library that works on iOS and Android. So you can embed a Unity scene inside your native application and then communicate or control it from the native side and pass data back and forth to updated states. And you can have a dashboard in Unity that communicates with the client, in WebGL. In the center is the broker, the MQTT server, and that can communicate to any devices that supports or that handles that protocol. So it's really a great way of working. And the next step, I guess, will be to look at how do we implement the Matter format. As I mentioned at the beginning of this session, Matter is a cross industry standard that's being developed with the backing of every single major player in the IoT or smart connected space. So definitely something that's going to gain traction and adoption, and then it will be just a matter of sending communication through that protocol, and anything that can support it will be able to interoperate. So that's really brilliant for moving forward. We need the same way you have HTTP to standardize how you communicate on the internet, we need a standard format to communicate for these IoT devices and platforms to interoperate.
All right, excellent. Okay, next question here. Can Unity connect with other messaging services? I mean, like JavaScript, web push, any messaging service already working?
Yeah, pretty much anything that's REST, WebSocket. John, I know you worked with a lot the WebSocket side of things. Yeah, pretty much. If
you go out and look at, there's a lot of, beyond like Hive and MQTT, there's so many different libraries and integrations. There's tons of options for getting data out of cloud services or REST services all over.
Yeah, there's a package which I referenced in my notes, but I'll post it in the forums. It's best HTTP2, I think. That's a commercial package you can buy that integrates a whole bunch of protocols like WebSocket, HTTP, obviously 1, 2, etc. But they also have an extension for MQTT, so you can use that to map out all your communications regardless of what you're targeting. Other than that, yeah, usually you'll find on GitHub, at worst case is you'll find a .NET implementation, which you can test inside Unity. We're using .NET, so it kind of makes things pretty straightforward. And if you don't know, .NET is basically what's used for Windows development. And since Windows is, still the leading desktop or development platform or in the world, the most services or providers will have a .NET compatibility layer, so you can integrate that into Unity, which today, for example, the MQTT messaging goes through a standard .NET library that just has a simple wrapper in Unity to connect to it, right? So it's pretty straightforward. I have yet to find a protocol that's not workable in Unity. It's a pretty open system.
All right, awesome. And we're just going to keep rolling right along here. Will Arduino work through wireless communication with Arduino, such as Bluetooth or Wi-Fi?
I'm not sure about Bluetooth, but Wi-Fi, yes. I believe there's a ESP8266, that extra board that I mentioned during the talk. If you have that for your Arduino, or if your Arduino is Wi-Fi capable, there is a Wi-Fi extension for the package to basically, it'll behave almost the same exact way that I described, where it's kind of running over a serial port, but it does it over your Wi-Fi. You need to put in the credentials for your connections, and it'll search to kind of connect to the other device. The only catch there is that if you want to use multiple devices on your Wi-Fi, you need to manually go in and set different ports for each one. They can't be the same port. But other than that, I believe the answer is yes.
All right, awesome. Okay, is HiveMQ free to use, or does it require a subscription?
So they have a free tier, no credit card required to sign up. And I believe it's 100 devices connected and up to 10 gigs of data. And then you'll have to work with them. But in the slide, as I showed, there's public servers you can use. If your data is non-sensitive, if you just want to tinker and you don't need the data to be private, then you can use the public servers from Mosquito with 2 T's because it's MQTT. And also the Eclipse project. If you do Eclipse MQTT, if you search that, they'll have public servers that you can use. Either some of them are encrypted also to add a little bit of security to your communications. But they are public servers to test. That's why I use at the beginning to test, but the performance, obviously, because it's a public server, is not great. So, I found HiveMQ, which, like I said, no credit card required and a pretty generous free tier. So recommend them. They're quite straightforward. Also, you can set up multiple clusters on Hive. I just have one right now for these demos, but you can have multiple ones so that, you can have multiple projects running separately, like sandboxes. So it's really useful.
All right, fantastic. Okay, still got a number of questions left here. Is there an equivalent for Raspberry Pi regarding the package to use in the Unity editor?
Perfect segue, John. I know John has been looking at the Pi root with his fancy Crow Pi. You have to show that thing. It's the best thing ever. Look at this. This is absolutely fantastic.
I'm gonna have to unblur. Oh, you can see my room.
Bomb detonator.
Look at this. I mean, wait. So you did mention you went through security with this thing at the airport.
They only have a couple questions. So that's a Crow Pi. It's a Raspberry Pi based testing board. So it's got a lot of different hardware and breadboards already integrated to it and wired up for you with a monitor and all that. So the answer is that it's not exactly equivalent, but if you want to work with Raspberry Pi, you can think more Arduino is more like a microcontroller, you can almost think of it as a stand-in for an embedded system, right? It's kind of it's doing its own thing. It's always going to just do its own thing. Raspberry Pi is closer to a PC. It's basically closer to a Linux machine that you'd be running. So it doesn't work exactly the same way, whereas you wouldn't consider plugging your laptop into another computer to then run, right? You would want to share the data another way. So for the Raspberry Pi, there are many options to do the similar things. We didn't talk about them today just for time. We couldn't cover everything. But one of the things that I've been working with was a Raspberry Pi and then connecting to Azure, like IoT Hub, or you could use MQTT, but you could actually write the code and the things you want to do directly on the Pi to connect to the internet and send the data to that service. And then the other side of that service, that connection is the same as what we saw today. So if you wanted to consume, if the Pi was writing to that same MQTT broker, the Unity side wouldn't change at all. It's just receiving data from those topics, and it would work the same way. We didn't cover the integration with Azure and whatnot, but Unity has direct integrations with Azure, and also even Microsoft has. If you go to the Microsoft Learn sites, maybe I can find the links and share them in chat momentarily, that there's a couple of sites on the Microsoft Learn platform that has instructions on how you'd actually connect a Raspberry Pi to send data to Azure. And I believe that there's support for C and Node.js right out of the box, and some other things like that. So the short answer is you can absolutely use Raspberry Pi and all the sensors connected up to that. It's just you do it a slightly different way. The data reception side, it would all be the same.
Actually, what's beautiful about this analogy, John, that you had is you can the Arduino is really, like you said, the embedded device that's going to be like the light device that's going to be inside a device like a sensor or a smart thermostat, right? And then the Raspberry Pi, you can actually run the MQTT server itself, the broker, on the Pi and connect to that from a Unity instance. If you want to create a self-contained system that doesn't go to the interwebs, that's a great way of doing it, and something that the Pi is capable of. Posted on the chat, someone was asking about ESP32. right? Devices, yes. Boards, and I posted a link to a tutorial which has the Raspberry Pi in the center that's used as the MQTT broker in order to connect connected devices like that. I think it's an Arduino board with a wireless capability, so you can do it this way. But yeah, the Pi is obviously much more capable. It's a full-fledged computer compared to an Arduino.
And I just dropped a link in chat for if you're looking for examples on how you would connect a Raspberry Pi to like Azure specifically. I just dropped a link in chat for that.
Yeah, and shameless plug, the CrowPi is a project you can buy, right? It's just self-contained, it's got a screen, got everything you need.
Yeah, I mean, in the end, it kind of functions like a laptop that, you know, it's just covered in hardware and other sensors and devices as opposed to just like a keyboard and whatnot. Although there's newer versions that also have a keyboard kind of overlay underneath all the stuff.
I looked on the website, but I you know, it's a bit pricey, so I need to find a justification.
Raspberry Pis have gone up in price quite a bit in general also, so just bear in mind.
True. All right, fantastic. Thank you, John.
All right, pardon me for the dead air there, just responding to a question in chat. But some people looking for our recorded sessions from previous webinars. Our December session is coming soon. It's just pending final review, and today's session will take a few weeks between, you know, editing and uploading, and it'll be made available just at the link that I posted in the chat there. But anyway, getting back to Q&A, will there be an Omniverse and Unity session in the future?
Oh, we didn't program this because unfortunately there was no, when we started, Ben and I curated the series over a year ago now, and there was no official connector for Omniverse. There was a topic that we wanted to address, but it would have been a bit complicated to create a demo without an official connector. So now that we have it, it would be good, but unfortunately, I don't think we'll have time in this series, but it's definitely something that you should see a lot of collaborations between NVIDIA and Unity and promotion of the connector now, which is a long awaited development in this ecosystem. So I don't think we'll do it in this series, but it's definitely something that's going to pop up hopefully in upcoming sessions from our advocacy team, looking at how to implement that and use this service. Yeah.
All right, awesome. Is there a support for GraphQL, HTTP plus WebSocket?
Yes, I mean GraphQL, I believe so, because that's just a database connection, if I remember correctly. I don't know if there's native support inside Unity, but the WebSockets, etc. Yes, that's supported either natively or through third-party packages for specific implementations. John, you have?
There are open source. If you just search Unity GraphQL, you'll find some GitHub projects that do that, and there's also, I believe, assets on the asset store that also provide GraphQL connection.
I think the one I mentioned, Best HTTP 2 may have GraphQL support. Check it out. It's a bit pricey, but if you need this for a production project, it has really good reviews. So yeah, if you can't find it on GitHub, look at the asset store, and usually you'll find a solution for whatever you need to connect to.
All right, awesome.
Thank you, John.
Yeah, thanks, John. Just a couple questions left here. What if we could connect AR to this kind of project? I mean, like, what if I use AR virtual buttons as these controls for legacy UI buttons in MIDI?
Yeah, 100%. Yeah, this as I showed, the user interface in the editor is just a regular 2D user interface, but you can take that canvas, make it in 3D space, and use the HoloLens controls, or just if you download or use, for example, MRTK for your AR development for HoloLens or Quest, then it comes with a slew of UI controllers, UI components, including sliders, knobs, etc., which you can use, and push buttons actually, which you can use and map to this. Right, they're just really simple to integrate. So yeah, 100%. It's exactly the idea. Is once you're in Unity, then the sky's the limit. Even
absolutely.
that's not even a limit, but yeah.
All right, last question here before we do our unofficial sign off before overtime. The IoT follows the same execution of the Unity lifecycle. So it follows like a start, update. Do you have to build another execution lifecycle for executing the application process for IoT?
No. Sorry, go ahead, John.
Well, I'm not sure I tracked the question exactly, but I think what you're asking is that when we're working on the Arduino, is it running its own life cycle, or is Unity driving that somehow? And if that's the question, then the answer is no. The Arduino runs its own code. So I showed it briefly, the Arduino IDE. That is the code that runs on the microcontroller. When you compile that and then upload it, it goes on to the Arduino, and then you can basically at that point consider the Arduino as a self-contained system. So it's its own thing running its own life cycle. It has its own, it's not called start and update, it's called setup and loop, but it's similar where it's got like stuff that happens right at the very beginning, and then a looping process where it'll continue running the same things over and over again, like reading data out of the sensors or pushing or sending messages of the new sensor data that's reading in from the different pins. But that exists basically as a self-contained system. So if you had an Arduino or a system with a microcontroller on it, you would push that sketch or whatever type, code onto it, and it then runs on its own. It doesn't need to be hooked up to Unity at all. It's doing its own thing. But if then you can read it into Unity, and then Unity follows its own rules on the system lifecycle. So you'd be reading that data in over update, or you can do stuff like Jerome did, where we can kind of raise events where different things change and stuff like that.
Exactly.
So I hope that answered the question.
And on the MQTT side, the library, it's using async and await to actually, or maybe a coroutine, can't remember, but the .NET version uses async and await, so it's asynchronous basically, right? So it doesn't block your Unity execution, assuming you're on a multi-threaded system.
All right. So for now, it looks like that's going to do it for Q&A. But if anyone has any remaining questions, please fire them in there, and hopefully we'll be able to get to them before I'll officially sign off. But with that, let me just grab my meeting controls here. Thanks everyone for joining us today. Big thanks goes out to Ben Radcliffe as well, co-creator of the series, who couldn't be here today, as well as Jerome, Vanessa, John, all of our organizers as well. Keep an eye out for a follow-up email mentioning links to resources mentioned in today's talk. And of course, you can check out all the today's slides on the forums. One more reminder to please fill out that live session survey when you get the chance, just the QR code and link that I've just posted in the chat there. And yeah, we'll see you next month for our next session of the Road to the Metaverse Creator Series. But with that, Jerome, if you had any overtime, take it away.
No, actually, I was thinking we had more, more questions, but looks like we went through everything, so I think we're good. Unless
awesome.
We can wait a few minutes in case people have more questions. We'll wait until 5:30 my time, I guess. But other than that, yeah. Or we can keep playing with our sensors and get that CrowPy running, John. You need what, like 5 minutes to get that set up? Maybe a bit more. No, I guess that's it for us for this week.
Okay, awesome. Yeah, with that then, if that's, we got one more question. Will the Arduino scripts be posted too?
Yeah, we can put that on, well, actually it's part of the asset, so I don't know if we can share this because it's part of Arduino. But
yeah, we can link, if nothing else, we can link you to the templates that we use from Arduino to modify. But yeah, the baseline was from the asset, although it is modified. We probably shouldn't just give that.
Yeah, the creators work hard for this, so we can't really give it away for free. But yeah, check out Arduino, and then again, it's $15, which is a really amazing value for the amount of functionality that it delivers, and just the ease of use is insane. So highly recommend it.
All right, excellent. And where can I find this recording so other people can watch? We'll post that. I'll type that answer here, make that available in the Q&A. So as we said a little bit earlier, we're a little behind in some of our uploads, but we're getting caught up. So our December session is due to be uploaded very soon, hopefully by the end of this week. And today's session will take probably about 3 weeks before we see that posted on the same exact same link that you use to watch the live sessions as well. There should be a watch now and a register for future sessions. All right. And with that, I think that's it. Just gonna end our last question there. Thanks again, everyone, for joining us once again. And yeah, we'll see you next month for our next session of the Road to the Metaverse Creator Series. All right, take care, everybody.
Thank you,
Thank
everyone.
you. See ya.
Bye.
Bye-bye.